Hi, welcome back to S596 Machine Learning. And in this lecture, we're going to talk about linear regression model. So here's the brief outline of the lecture for this topic. So we will basically go through some background knowledge about data representation and why it is necessary to represent data properly. And we will briefly talk about the difference between unsupervised versus supervised learning, okay? And in the main part of this lecture, we will go through the topic of linear regression. We'll first define the task, okay? We'll talk about what problems that linear regression method is up to solve. And then we define some core concepts, cost function. And then we will introduce two methods that will be used to solve the linear regression model, to train a linear regression model, basically. So the first one is normal equation method, and the second one is called gradient descent, okay? So yeah, let's get started. Okay, so I hope you all remember the charts that I put in the previous lecture slide. So here's the basic mind map or a mind flow of how to set up a machine learning model. We need to have the blue part, which is data, and our model part is in the red rectangle here, and our parameters are the tools. The parameters are kind of the tools that are used to fit to the data, okay? And so we basically segment the training data and feed it into the model, and the model will adjust the parameters using the data it saw. And then with the new data incoming, the model is able to make some predictions depending on what the task is, like predicting whether email is spam or not, or predicting whether the house price is gonna increase or decrease, okay? So the question is, how do we represent the data? How should the data look like? How should the data be like? So, and to answer it, we basically need features to represent our data. Okay, so let's go into this simple task of predicting whether a fish is given the picture of a fish. We want to tell whether the fish is a salmon or a sea bass, okay? So it's a simple binary classification problem, right? But in order to, so think about the procedure, or think about the task is something that we want to solve it ourselves. So we want to learn it from scratch, okay? So what is the basic idea of human beings doing this task? Okay, so probably you will buy a bag of fish, right? And you can simply measure and observe and even touch or smell each fish, okay? And of course, you need some external knowledge, like an expert, like a fisherman, like a teacher that teach you for every fish in a bag. You should be told what it is, or you should somehow know what it is, okay? So this bag of fish is what we call a training data set, or training data, okay? But in order to learn, we need to define some features, okay? For example, given a fish, you want to take it out and measure its length, right? For every fish, measure its length, okay? So imagine we just use length, one quantity, as a feature, right? And then what if we just print it out, or we just draw on the paper about the distribution of the length, okay? Okay, so so here's the distribution plot. So it's a histogram plot. It's basically each bar or each column is the count of fish that falls into the certain length on the x-axis, okay? So the numbers on the x-axis is the length of a fish. So we can basically tell that there's about, let me take out the annotation. Okay, there's about 22 or 21 or so fish that falls into the 9-inch long, right? And about here, about 10 fish fall into the 17 to 18-ish inch long, right? So that's the basically accounts of the, based on the length feature that we use, okay? So given these histogram plots, we can kind of define a very naive classification model that tells whether it is salmon or sea bass, because from the histogram, we can see that the majority, let me use 2 colors, the majority of the salmon falls into this part, right? Because the black curves represents the salmon fish, and the red curve represents the sea bass. So you can see that the majority of the sea bass here is above, is on the right, is above 11 inch. Okay, so this threshold of 11 inch can be kind of a standard that we can use to tell the 2 kind of fish apart. Okay, so this can be an empirical boundary, right? So given a fish, we can simply measure its length. Then it's, if it's more than 11 inch long, then we can say it is more likely to be a sea bass. Or then if it's otherwise, if it's under 11 inch, then we can say, okay, it is more likely to be a salmon. All right, so we are building a our first kind of machine learning models. Even though we're doing it ourselves, it's not actually machine learning, but human learning. All right, but doesn't matter. This is basically how extremely simple machine learning models do, okay? So let's look at the model again, all right? We can use it to make predictions, right? So for any new fish, by which I mean not from our original bag of fish, but it's something new, and we get it and measure its length. Then if it's below 11 inch, then we say it's salmon. Otherwise, we say it's sea bass. Okay. So in this case, there's only one single feature used, which is length. Okay. And might be okay for most cases. It might not work for some others, right? Because in the chart behind, in the chart previously, we see there are noises here. It is still likely, it is still possible that a salmon is longer than 11 inch long, and the sea bass could be below 11 inch. Yeah. So this model is not perfectly accuracy, okay? So in order to improve the accuracy of the classification model, we can probably use incorporates other models.